Can you explain what is model evaluation in ML?
Sure. Model evaluation measures how well a trained model performs on unseen, test, data. It helps assess both accuracy and generalization capability. Different metrics are used for classification, regression, and clustering tasks. Example: evaluating a spam email classifier on test data to measure how accurately it identifies spam versus legitimate emails.
What is cross-validation?
Cross-validation is a resampling technique that divides data into multiple subsets folds for training and testing. It provides a more reliable estimate of model performance than a single train test split. K-fold cross-validation is the most commonly used method. Example: using 5-fold cross-validation, a model is trained on 4 folds and tested on the remaining 1 repeatedly, then the average accuracy is taken as the performance score.
What is a confusion matrix?
A confusion matrix is a 2D table that shows the number of correct and incorrect predictions for each class. It helps visualize classification performance and identify specific types of errors. From it, precision, recall, and F1 score can be derived. Example: in a spam detection model, the confusion matrix displays how many spam emails were correctly identified, true positives, and how many legitimate emails were wrongly flagged, false positives.
What is precision in ML?
Precision measures the percentage of correctly predicted positive instances among all predicted positives. High precision means fewer false positives. It's crucial in scenarios where false alarms are expensive or undesirable. Example: in a fraud detection model, high precision ensures only truly suspicious transactions are flagged, avoiding unnecessary investigation costs for normal users.
What is recall in ML?
Recall, or sensitivity, measures how many actual positive instances were correctly predicted. High recall means fewer false negatives. It's vital when missing true positives has serious consequences. Example: in a cancer detection system, high recall ensures that almost all cancer-positive patients are correctly identified for further medical testing.
What is F1 score?
The F1 score combines precision and recall into a single metric by taking their harmonic mean. It's especially useful for evaluating models on imbalanced datasets. A higher F1 score indicates a good balance between precision and recall. Example: in email filtering, where spam emails are rare, the F1 score helps measure overall model effectiveness more fairly than accuracy alone.
What is accuracy?
Accuracy is the ratio of correctly predicted instances to the total number of predictions. It's most meaningful when class distribution is balanced. In imbalanced data, it may give a false sense of good performance. Example: if 95% of emails are non-spam, a model that predicts all emails as non-spam achieves 95% accuracy but fails to detect any spam, showing why accuracy alone can be misleading.
What is ROC and AUC?
ROC, Receiver Operating Characteristic, curve plots true positive rate versus false positive rate at different thresholds. AUC, Area Under Curve, summarizes this performance. Closer to 1 indicates a better model. It's often used to compare multiple binary classifiers. Example: comparing a logistic regression model, AUC equals 0.95, and a decision tree, AUC equals 0.85, for credit risk classification. The higher AUC model performs better across thresholds.
What is the bias variance trade-off?
It refers to the balance between a model's ability to generalize, low variance, and its simplicity, low bias. High bias, underfitting, high variance, overfitting. The goal is to find the right balance for optimal test performance. Example: a very simple linear model underfits complex data, high bias, while an overly deep neural network fits the training data perfectly but fails on new data, high variance.
What is regularization?
Regularization techniques reduce overfitting by penalizing large model weights. Common forms include L1, lasso, and L2, ridge, regularization. It helps create smoother, more generalizable models. Example: in linear regression, L2 regularization, ridge, limits the size of coefficients, preventing the model from fitting noise in training data and improving test performance.
Well, I'm happy to say you are selected. Congratulations.
Thank you, sir. Thanks to ZoomInData for their real-time projects, mentorship, and constant support. ZoomInData didn't just teach me tech, they gave me direction.